Okay, you gotta love this problem, right? Some nuts and bolts here. So what they're saying is this distance here, okay, this 654, that's the distance from here to here, the top of the ball to the bottom of the ball, right? So the ball is going to fall, the center mass of the ball, notice it starts the radius of this, right? And by the way, the radius of this sphere is 6.0 plus or minus 0.05 millimeters, right? That would be the radius of it. So it starts that much below the point of release and it stops when it's that far above, right? So the distance that it falls will be this number minus 2 of those, right? Now remember, when you subtract numbers and add numbers, you always add the absolute uncertainty, right? So for example, 2 plus or minus 0.1 minus 1 plus or minus 0.3 is 1 plus or minus 0.4, right? So remember that fact, right? So as you subtract this radius twice, you're going to add this uncertainty 2 times, right, to this uncertainty. So you're going to end up with, I'll call it XA, right, plus or minus the uncertainty of XA, right? Okay, you end up with a value, and I think you can get it, right? On the next part here, they're asking you to plug that number in there. So whatever you got for the part A, that's going to go there, and then the measured time to fall on the previous page, you can see it's 0.363. Right? Don't forget to square it, plug it in, and you'll get some value, right? And I got between, if you do it in meters per second squared, I got between 9.7 and 9.8. Okay, so don't worry that it's not 9.81. Then you have to estimate the absolute uncertainty. So this is a propagation of uncertainty. Okay, so I'm going to say that this is equal to G, right? So the uncertainty of your value of G, which is what you're trying to calculate, right, is to the value you got. Okay, so whatever that value is, you get the number that's like between 9.7 and 9.8. Put that right there, okay? And that's going to equal the uncertainty of XA. That's from the previous question over whatever XA, whatever that distance is, right, that the ball falls, that true distance from here to here. I'm calling that XA, right? And then it's got some uncertainty. We'll call it delta XA, right? So put that there, right? Because that's in the thing. And then you're going to say plus, since that's squared, you'll do 2 of these, the uncertainty of time over what the time was, okay? On the previous page, you'll see that what the time is 0.363 and the uncertainty of it is 0.002, okay? Plug that in and you'll get a value. Now, remember how last year we were talking about the uncertainty? What you want to do, I believe, is round this thing to 2 sig figs, okay? And it's somewhere between 100 and 150 millimeters per second, or 0.14 and 0.15 or so meters per second squared, right? Okay. And what you want to do is you want to write the value of G, say if G is 9.79 and your uncertainty of this is 0.17, right? 25. You want to write these with the same digits. So you're going to say plus or minus 0.17, okay? So you want if you're going to write a hundredths place, the uncertainty needs to have a hundredths place, right? Alternately, you can round it to the tens place and round your uncertainty to the tenths place and the tenths place. See if you can get it right.